Hi again guys, so this is the third part of our video on the analysis of doubly reinforced beams. So bali no guys, no, this time we are going to solve another problem, another example problem, and this problem is in English na units. Okay, so bali no, determine the design moment capacity of the beam shown in the figure for which F sub y is equals to 60,000 psi and F sub c prime is equals to 4,000 psi. Okay guys, so this is our beam guys. So bali no, we have this compression bars na dalawang number 7 na bars, tapos tension bars na apat na number 10 na bars. Okay, so ayun, so let's solve this problem guys. So bali no, to start with, no, let's begin by writing the given sa problem. So bali no, yung ating mga given guys, F sub C prime is given, that is 4,000 psi, tapos F sub Y is also given 60,000 psi. Yung width ng ating beam guys is 14 inches, so that is B. Tapos of course, the effective depth is also given. So yung effective depth is from the centroid of our tension bars up to the extreme compression fiber, so that is 24 inches. That's 21.5 plus 2.5. And then of course, we have D prime. D prime is the distance from the centroid of our compression bars to the extreme compression fiber. So that is 2.5 inches. Okay, so let's begin now guys with computing for the area of compression bars and area of the tension bars. So bali no, take note that for bars up to and including number 8, the number of the bar coincides with the bar diameter in eighths of an inch. So in other words guys, since number 7 man yung ating bar, yung ating diameter nito is 7 over 8. So bali for the AS prime, that is pi over 4 multiplied by the diameter, which is 7 over 8 squared times 2 kasi we have 2 bars here. Okay, so of course, our AS prime will be equal to 1.2026 square inches. Okay, para naman guys sa ating tension bars, so bali take note that for number 9, number 10, and number 11 bars, they have diameters that provide areas equal to the areas of the old 1 inch by 1 inch square bars, 1 and 1/8 inch by 1 and 1/8 inch square bars, and 1 and 1/4 inch by 1 and 1/4 inch square bars. So in other words guys, for number 10, yung area niya follows the area of 1 and 1/8 inch by 1 and 1/8 inch. So that is 1.125. So para makuha natin guys yung AS, that is 1.125 times 1.125 kasi square bar yun guys, no? So bali no, sinusunod niya nga yung area ng square bar. So yung area ng square bar is yung area ng ating number 10 na bar. So times 4 guys, because we have 4 na number 10 bars sa ating tension side. Okay, so of course our AS here will be 5.0625 square inches. Okay, so next now is we can now start with our analysis for doubly reinforced beams. So, ayun. So, bali no guys. So, ang gagawin muna natin is, ganun pa din guys. So, katulad nung sa naunang problem sa past na video is, gagamitin natin yung equilibrium equation assuming Fs prime is equals to F sub y. So, bali no, gamit itong F sub S prime equals to F sub y, ina-assume natin na yung compression steel will yield. Okay? So, bali no guys, no. So, ang gagawin natin muna is, gumawa muna tayo ng force diagram katulad nung sa dati. So, bali no, of course, we have tension force in here. That is equals to AS multiplied by Fy. Yung AS dito is the area of our tension bars. So, of course, we have here the compression concrete force, which is 0.85 F sub C prime multiplied by A times B. Okay, so of course, no, yung ating compression concrete force will act at the centroid of our concrete compression area. So, in other words, this will act halfway sa A. So, in other words, this distance will be D minus A over 2. Okay, then, of course, meron din tayong force, guys, galing sa ating mga compression bars. So, bali, ito na yung ating compression steel, which is equals to AS prime multiplied by F sub S prime. Okay, so, of course, yung distance neto from the extreme compression fiber is D prime. Alam na natin yan, no? So, bali yun guys, no? So, bali no, para sa ating equilibrium equation, that is simply tension force is equals to compression concrete force plus the compression steel. So, ayun, so bali no, ang gagawin lamang natin, of course, is isusulat natin guys yung mga formula ng bawat isa dyan. So, ayun na nga. And then, take note that we are going to use Fs prime equals to F sub y kasi nga ina-assume natin that the compression steel is going to yield. Okay? So, ang mangyayari nito guys, no, is ang ating magiging unknown na lamang sa equation na to, pag sinubstitute natin lahat ng mga known values, no, ay yung A na lamang yung ating unknown. Okay? So, given na guys yung iba dyan, no, A na lang yung wala. Okay? So, in other words, guys, makakompute natin si A dito, and that will be 4.8654 inches. Okay, so take note guys, na kinuha natin yung A na to based on the assumption that f sub s prime is equal to f sub y. So in other words guys, kapag ka later on na-find out natin na hindi pala equal si f sub s prime kay f sub y, mali itong value ng A na to. So hindi nyo na to dapat gamitin kung hindi pala equal si f sub s prime kay f sub y. Okay? So yun guys, no? So i-compute natin si C, which is A over beta 1. So kailangan natin ng beta 1 dito guys. So of course, gagamitin natin sa yung ACI na code kasi nga this is an English unit na problem. So of course, sabi sa ACI, yung ating beta 1 nga daw is nakadepende sa value ng f sub c prime, which is, yung ating f sub c prime nga is nandito sa table, which is 4,000 psi. So of course, dito siya nabibilong guys, no? So that means that our beta 1 is equals to 0.85. So of course, kapag kasi substitute natin guys si beta 1 at saka si A sa ating equation, then yung ating C will be 5.724 inches. Okay, so now guys, na na-compute na natin si A at saka si C, then kailangan nating malaman kung totoo ba na yung assumption natin. Di ba nag-assume nga tayo kanina that f sub s prime is equals to f sub y. So that means nag-assume tayo na nag-yield nga yung ating compression steel. So now, let us find out kung tama ba yung assumption na yun. So we have to compute the strain in compression steel, that is epsilon sub s prime. That is to verify the assumption that the compression steel will yield. Okay, so bali no, ang gawin muna natin guys is gumawa tayo ng strain diagram. So ito na nga yung strain diagram. So of course, yung ating strain sa concrete is 0.003. And ito, ang tawag natin dito is the compression steel strain. Ayan yung ating i-compute natin ngayon. Okay, tapos of course, ito is the tension strain. Okay, so yun, so ilagay na lang din natin yung ating mga dimensions. So ito yung ating effective depth guys mula sa extreme compression fiber papunta sa centroid ng ating mga tension bars. Ito is C, okay? Tapos, ito is D prime. So ibig sabihin, this one will be C minus D prime. Okay? So take note, malalaman natin kung yung ating compression steel ba ay mag-yield or hindi by comparing it to the yield strain na value. So kung yung ating compression steel strain is greater than or equal sa ating yield strain, then that means that the compression steel is yielding. So kapag ganito yung nangyari, tama yung ating assumption kanina. Okay? Kung yung ating compression steel strain is less than sa ating yield strain, ayun, so that means the compression steel is not yielding. So ibig sabihin, mali yung ating naging computation kanina. Okay. So yun na guys, so ratio and proportion lamang. So itong triangle na red na ito is similar to this maliit na triangle na to. So bali no, ratio and proportion, 0.003:3 is equal to the compression steel strain divided by C minus D prime. So bali itong side na to divided by this side, okay, tapos itong side na to divided by this side. Okay. So ayun, so bali na compute na natin guys yung C at saka yung C kanina ay na-compute na natin, yung D prime is given na sa problem, that is 2.5 inches. So ibig sabihin mako-compute natin dito guys si compression steel strain, and that will be equal to 0.001690. So ngayon no, ang gawin natin ay i-compare natin siya sa ating yield strain. So ano ba yung ating value ng ating yield strain? So for the yield strain, that is equal to F sub y divided by the modulus of elasticity ng ating steel. F sub y is already given guys, that is 60,000 psi. Of course, constant yung ating modulus of elasticity ng steel, and that is 29 times 10 to the 6 psi. So ayun, so makukuha natin guys dito sa ating yield strain, which is 0.002069. So now, let us compare the value of our compression steel strain to the yield strain. So take note that our compression steel strain is 0.001690. So this is less than sa ating yield strain na 0.002069. So dahil less than siya guys, ito yung nangyari. Okay? The compression steel is not yielding. So in other words guys, yung ating F sub S prime is not equal to F sub Y. So, ibig sabihin, the assumption was wrong. So, kung mali yung ating assumption, guys, ibig sabihin yung na-compute kanina natin na A at saka C, mali yun. No? Hindi na dapat yung gamitin yung A at saka C na yun. Pati na din itong compression steel strain na to kasi gumamit tayo dito ng C na mali. So, mali yung mga na-compute natin kanina. So, ngayon, ang gagawin natin, ano na yung gagawin natin kasi nga assumption natin ay mali. Babalik tayo sa ating equilibrium equation pero this time, hindi na natin i-assume that F sub S prime is equal to F sub Y. Okay? So this time, compression steel is not yielding kasi sure na tayo na hindi siya mag-yield. Okay? So based sa atin guys na equilibrium equation kanina, that is tension force equals to compression concrete plus the compression steel. Ayun, so isusulat natin ulit yung ating yung formula. Okay? So, ito yung mga formula ng bawat isa sa kanila, no? Alam na natin yan, okay? So, ayun guys, no? So, bale, no? Alam natin na C is equals to A over beta 1, okay? So, of course, no? From here, from this table, alam natin that the beta 1 is equals to 0.85, diba? So, alam na natin yan kanina, ano na natin yan kanina. Okay, so ibig sabihin guys, by this relationship guys, pwede natin makuha yung A with respect to C that will be equal to A nga is equals to 0.85 C. Okay? So, yun lang guys, no? So, gagamitin natin yan. So, bali express natin guys mamaya. Di ba kaya yung unknown lamang dito sa equation na to will be A at saka yung F sub S prime. Kasi hindi natin na pwedeng gamitin yung F sub S prime equal to F sub Y kasi nga hindi naman sila equal. So, again guys, no? Yung iba dito na element sa ating formula ay alam na natin, given na siya sa problem, yung unknown na lamang dito is yung A at saka yung F sub S prime. So, yung A, express natin siya with respect to C. Tapos, yung Fs prime ay express din natin siya with respect to C para makuha natin yung C at saka A, no, sa equation na to. Okay, so bali, no, alam natin that the compression steel strain is equals to the Fs prime divided by the modulus of elasticity ng ating steel. Okay. So, of course, yung ating modulus of elasticity that is constant, that is 29 times 10 to the 6th or 29 million PSI. Tapos, based sa ating strain diagram, we can have a relationship ng ating compression steel strain at saka ng C. So, yun. So, ratio proportion lang yan, guys. No? 0.003 divided by C is equals to a compression steel strain divided by C minus D prime. So, yung D prime is given, that is 2.5. Okay? So, yun. So, bali, no, makukuha natin dito, guys, yung ating compression steel strain with respect to C. So, ayun. So, bali, no, meron na tayo, guys, eto na modulus of elasticity at saka compression steel strain. So, pag kinuha natin, guys, si F sub S prime, kaya makukuha natin is yung F sub S prime with respect to C. So, ito na nga yung, guys. So, ayun. So, ang gagawin lamang natin is i-substitute si F sub S prime at saka si A. Okay, na parehong with respect to C sa ating equation. So, ang mangyayari is, dito sa ating equation, ang magiging unknown na lamang dito is yung C, no? So, ganyan. So, okay. So, ayan na nga guys, no? So, nakompleto na natin. Ito na nga yung ating equation. So, again, yung mga yellow na yan is given na sa problem. Itong light blue is nakuha na natin mula dito sa mga solution natin dito. Okay. So, ayun. So, dito, no? Kung nakikita natin, C na lang yung ating unknown dito sa equation. So, of course, no, pwede nating makuha dito si C and C will be equal to 5.9919991 inches. Okay. So, dahil nga dito sa relationship ni A at saka ni C na A is equals to 0.85C, then makukuha natin si A na 5.0993 inches. Okay. So, ngayon guys, no. So, ito na yung nakuha natin guys na value ng C at saka value ng A. So, ang gagawin natin is, kailangan natin i-compute ulit yung ating compression steel strain, no, para ma-verify natin na yung compression steel nga ay hindi mag-yield. Kasi alam naman natin na hindi siya mag-yield. Pero, para lang ma-sure tayo na walang mali sa ating computation, i-compute natin si compression steel strain. Okay. So, again, strain diagram, guys. This is 0.003. This is the compression steel strain. At tapos, ito yung ating tension strain. Okay, so again guys, ito yung ating mga dimensions, huwag natin kakalimutan. Ayun, so bali again guys, no, para malaman natin na hindi mag-yield yung ating compression steel strain, dapat yung ating compression steel strain will be less than the yield strain. So ito nga dapat yung mangyari. Okay? So ayun, so ratio proportion lamang guys, itong triangle na to is equal to, is similar to this triangle. So ratio proportion sila. So 0.003 divided by C is equals to compression steel strain divided by C minus D prime. Okay, so gagamitin natin dito guys na C is yung kinompute natin na C, no? Kasi ito yung inassume natin na hindi equal si F sub S prime kay F sub Y. So, hindi siya mag-yield. So, ayun. So, kailangan kasi natin ma-verify na hindi mag-yield. So, ito yung gagamitin natin na value ng C. Okay? Of course, yung D prime is already given. So, ang mangyari dito, the compression steel strain is 0.001750. Okay, ngayon guys, no? I-compute ulit natin guys si yield strain. Wala namang magbabago sa ating solution kanina, no? Same lang yon. So, yung ating yield strain is 0.002069. So, ngayon, i-compare natin siya guys sa ating compression steel strain, and take note, our compression steel strain na 0.00175 is less than sa ating yield strain. So therefore, ito na nga yung nangyari, so hindi siya mag-yield. So ibig sabihin, tama na yung ating naging equation sa last. No? So tama na yung ating value ng C at saka yung A. So tama na yung value natin dyan. So correct na yun. Okay, so ayun, so makukompute natin guys dito si F sub S prime using this formula. So F sub S prime will be equal to 50,750 PSI. Okay? So, ayun. So, after natin guys makompute si F sub S prime, then, pwede na natin ngayon i-compute si tension strain. Okay, so, paano natin makocompute si tension strain? Of course, ratio and proportion lang din guys. Itong triangle na to is similar to this malaking triangle. So, ayun, so ratio and proportion, that is, itong side na to is tension strain plus 0.003 divided by this side which is the effective depth is equals to itong side na to 0.003 divided by this side which is C. So ayun, so nakuha na natin guys si C. Okay? So ito yung ating gagamitin guys na C, no? Kasi ito yung tamang value, yung C na 5.9991 inches at saka yung A na 5.00993 inches. Okay? So yung D of course is given na, so bali makukuha natin dito si tension strain which is 0.009002. Okay? So, base sa table na to mula sa ACI 31814, guys, no? Sa table 21.2.2, no? So, bali, no, makaklasify natin yung ating beam, no? According to this classification. So, pwede siya maging compression controlled, transition, o di kaya tension controlled. Okay, so bali, no, we know that our tension strain is greater than 0.005. So, in other words, dito siya nabibilong guys sa row na ito. So in other words guys, this is tension control. So take note na kapag tension control yung ating gagamitin na value ng phi nandito sa table which is equal to 0.90. Okay, so ngayon guys, naalam na natin yung ating value ng phi which is equal to 0.90. Then pwede na natin ngayong makompute yung ating design moment strength ng ating beam. Okay, so bali no, para sa design moment capacity or PMN, then gamitin natin itong figure guys, no, para mas maintindihan natin, no. So alam natin itong figure na to, na-explain ko na to sa mga nakaraang video. Okay, so bali no, para sa design moment capacity, we know that T1 at saka T2 is the yung total nilang dalawa is the total tension force. Okay, so bali no guys, no, kailangan muna kasi nating makuha dito yung AS1 at saka AS2. So bali, take note that AS or the total area ng ating tension bars is equals to AS1 plus AS2. So yun, so ito na nga guys, no, yung ating equation na gagamitin para makuha si AS1 at saka si AS2. Okay, so take note that etong T2 at saka C sub S ay equal lamang, parang katulad ng T1 is equal to C sub C, no? So ibig sabihin, we can equate AS2 Fy at saka si AS prime F sub S prime. Okay? So bali, gamit ito ay makukompute natin guys si AS2, no? Kasi nga, F sub Y is already given. Yung AS prime is alam na natin to. Sinob na natin to kaninang una pa lang ng ating part ng solution. Tapos yung F sub S prime ay nakompute na natin to kanina which is 50,750. Nandito na nga siya sa table guys, no? Okay, so ayun. So bali, AS2 is equal to 1.0172 square inches. Okay? So ngayon guys, no, alam natin sa AS2, then alam din natin si AS kasi nga kinompute natin siya kanina pa lang sa unang part ng solution, that is 5.0625. So ibig sabihin makukuha natin guys dito si AS1 which will be equal to 4.0453 square inches. Okay, so ngayon guys, na nakuha na natin guys, alam na natin si AS1 tsaka si AS2, then we can now start computing the design moment capacity, that is VMN. So para sa pag-compute ng VMN, alam natin guys na yung VMN is simply the sum ng couple na na-create ni T1 at saka ni C sub C at saka yung couple na na-create nila T2 at saka ni C sub S. So that will be, yung couple na na-create nila T1 at saka C sub C is T1 multiplied by D minus A over 2. Di kaya C sub C multiplied by D minus A over 2. Tapos yung couple naman nila T2 at saka C sub S, that is, yung kailang moment is T sub 2 multiplied by D minus D prime o di kaya C sub S multiplied by D minus D prime. Okay. So yun guys, no, so bale, no, ang gagawin lamang natin sa pag-compute ng VMN is equals to phi multiplied by yung sum ng dalawang ito. Okay? So yun na nga guys, madali lang naman i-compute si T1, that is AS1 times Fy. Na-compute na naman natin si AS1, si Fy is given. Si T2 din, alam na natin si AS2, Fy is also given, is given. Okay? So bale, no guys, no, so substitute lamang dito and makukuha natin si VMN and that will be 5,866,717 pound-inch. Okay, so bali no, kailangan natin usually na unit dito is keep feet. So, i-convert lamang natin siya to keep feet. So, ang mangyayari is VMN is equals to 488.89 keep feet. At eto na nga guys, yung design moment capacity na tinatanong sa problem. Okay? So, I hope naintindihan nyo guys yung ating solution. So, ayun. So, again guys, para sa problem na to, yung sagot is 488.89 keep feet. And eto na nga yung ating final answer. So yun guys, so kung meron kayong tanong about sa ating naging lecture or tutorial discussion, no, sa tatlong parts ng ating ng video, no, ng doubly reinforced beam, ng analysis ng doubly reinforced beam, no. Send me your questions or di kaya pwede naman kayo magtanong sa comment section guys dito sa YouTube, no. Sumasagot-sagot naman ako sa mga tanong. Okay? So please don't forget to like and subscribe to my channel guys. So thanks and see you sa ating next na mga tutorials. Bye-bye! Shoutout nga pala kay Engineer Tracy Bation. Hi Trace!